In the previous lecture, I have told you about the difference between compiler and interpreter. Now we have to look at hybrid type of compilers. Means hybrid compilers are compiler as well as interpreter. So Python is a hybrid compiler. Python's compiler is a hybrid compiler. So when we are learning about what is hybrid, we are also learning how a Python program runs. So let us see how Python compiler works or how a Python program runs. Now look at here. See, if you have written a Python program, program name is program.py is the file extension for Python programs. So this is a source code. That is a program code. So once you write this Python program and when you want to run it on this machine, so you'll say Python and give the program name. So the command is like this. You say Python and you say program.py. So you are calling Python compiler and saying that I want to run this file. This is what you do. On your C prompt, you can do this one. Okay, you will see that in the next coming lectures, how to run a Python program. So when you are saying you want to run the program, you will call Python compiler. So what does it do? It will compile this source code into intermediate code called bytecode. So actually it should convert into machine code. No, this compiler will not convert into machine code. Python compiler will not convert into machine code. It converts into bytecode and it generates one hidden file. Actually it cannot be seen. So the file name is program.pyc. So it was py, but now it is compiled file. So this is pyc file. So actually file is not created on the hard disk. So we say a file is created on the fly. So only it's inside the memory. So this is the bytecode. So compiler converts into bytecode. Actually, it should convert into machine code. What is the use of converting into bytecode? Let us see. See, when the compilation is done, compiler will check if there are any errors in the program. If there are no errors, then it will convert into machine code. So it has not converted to machine code, but it has converted into bytecode. But one thing is guaranteed, that this bytecode is not having any errors, no errors. This is error free. This is ready to run. So compiler has finished one part, that is it has checked that there are no errors. So if there are no errors, it has given a bytecode. Now this is ready to run. Now comes interpreter. Earlier I have shown you that interpreter will translate into machine code. So it will translate the source code into machine code. So it will also check for the errors. But now interpreter doesn't have to check for the errors. Interpreter will not check for the errors because already the bytecode is error free. So what it has to do? Just it has to translate this bytecode into machine code, that is machine language. So Python's interpreter will translate bytecode into machine code and execute. It may be doing it line by line and also getting executed machine code and also execute machine code then execute. It may do it line by line, or else it may convert this entire bytecode into first machine language then execute it at once. So it may be doing either line by line or the entire code. So if it is doing for the entire code, then we say that this interpreter is a just-in-time compiler. I told you already. So it is done by just-in-time compiler. So this type of interpreters are just-in-time compiler. So just-in-time compilers are a little bit faster. So this interpreter uses JIT compiler. So it will convert bytecode into machine code and execute. So this became a two-step process. In one step, bytecode is generated. In another step, first byte code. Next step, machine code. And who is executing it? Interpreter is getting it executed. So what is the runtime environment provided by this interpreter of Python? We call it as Python Virtual Machine, PVM. It is called as PVM, Python Virtual Machine. That's it. So this is the type of hybrid compiler which is having compiler as well as interpreter, two things. And there is the intermediate code generated, that is bytecode, and the file type is pyc file. If you want to create a file, you can create it. But usually it is not seen. If you really insist that no, I want this file, then you can get this file and you can execute it. So one benefit of converting into bytecode, I will explain you. Listen carefully. See, you have a Python program. You convert it into bytecode and you have a pyc file. This is not source code, neither source code, not machine code. It's an intermediate code. Now you have this pyc file. You don't need source file now. Whenever you want to run, you can run it via interpreter. always you can run it via interpreter. So interpreter will translate into machine code and execute it. So one burden is reduced on the interpreter, that it doesn't have to check for the errors. Simply it can translate and get it executed. So it's a two-step process. You can keep hold of this file and you can easily run it faster upon the machine because half of the work is already done by the compiler. So the remaining part of the work is done by the interpreter, that is converting into machine language. So you can make use of these PYC files easily in Python. Usually when we write and compile and run the programs in Python, we follow these two steps simultaneously. If you want to separate the steps also, you can do that. So that's how the Python compilers are hybrid. They use both compiler as well as interpreter. So this is how Python program runs. When you run a program, it gets compiled and then interpreted and executed by Python virtual machine, that is PVM. That's it. We have learned about hybrid type of compiler. Now if you ask me how Java works, it works in a similar way, and C# also works in a similar way. If you are learning those languages, you can find out about them. Procedure is same, file names may change, and the environment name may change. So Python works similar to Java and C#.NET. So it's a hybrid compiler. Now because of being hybrid, it's having its benefit. So what is the benefit? I will explain you in the next lecture. So that's all in this video. We have seen how a Python program runs.